Welcome to the BodhiAcademy. In today's video, we are going to continue with our PYQs series of class 10 subject science. So today we are going to do our PYQs on the chapter 3 metals and non-metals. Now in this chapter we have usually 2 to 3 marks questions which are asked, and they are asked based on a certain sentence that is picked up from our textbook itself, and based on that they have asked the following questions. Now, one important thing to remember in this chapter, one very important topic to know from this chapter is this activity series or the reactivity series that we know. So, now in this we have many metals telling us which is the most reactive and which is the least reactive. Now, sometimes it gets difficult to remember a series like this. So, to remember such series, we have already done previously a video on PYQs on the chapter chemical reactions and equations. In that, we have covered up tricks to remember this activity series. So, if you haven't watched it, please go and watch that one first. So, now let's continue with this chapter. So, the first question from this chapter is, a metal A which is used in the thermic process when heated with oxygen gives an oxide B which is amphoteric in nature. Now we have to name both the metals that are there, metal and the oxide. So we have a metal A which is used, they are saying it is used in a thermic process. Okay, this when reacted with oxygen, it is giving us a product B which is a oxide. Now, if we look at thermic process, we know one very important reaction from the entire chapter, that is the thermite process. Okay, now in this thermite process, we know that there is evolution of a lot of heat. Okay, so it is a highly exothermic reaction. So one very important metal that is associated with this reaction is that aluminium. So over here, our A, the metal A is our aluminium metal. Now we know any metal when it reacts with oxygen, it is going to form some kind of oxide. So over here, Al2, if we reacted with oxygen, it is going to give us Al2O3, which is aluminium oxide. Now in the question, they gave us a hint saying that this B which is there, the oxide which is formed, it is highly amphoteric in nature. So we know that aluminium oxide is highly amphoteric in nature. So over here, a B oxide which is there, that is aluminium oxide. Now the same question has another following question. Write down the equation for the reaction of B with NaOH. So we have B Al2O3. This we are going to react it with NaOH. So what is going to be its product? So over here we are going to get NaAl2O3. So this is NaAlO2. So this is sodium aluminate plus we are going to get water. So this is sodium aluminate. So when we react aluminium oxide with NaOH, we are getting sodium aluminate plus water. Moving to the second question. When a metal reacts with an acid, it produces a gas. So the first question is, we have to, which is the gas produced. So this is the first question, we have to tell which gas is produced. And second one is, we have to write the formula for the gas that is produced. Now we need to know that when metal reacts with an acid, it gives us a basic reaction. We get a salt plus we have a hydrogen gas that is released. So over here they have asked only to mention the gas. So in this case the gas is hydrogen gas, and its following formula we write it as H2. Please be careful. not to write just H over here. H corresponds to hydrogen, but H2 tells us that it is a molecule of gas. Moving to the third question. So we have a statement over here. Extraction of metals from their ores involve various steps. So the first question asks us to write a difference between roasting and second between calcination. Okay, now first let's understand roasting and calcination. Both are a method of heating any metal oxide. Okay, so in this case both are a heating process itself, but what is the major difference that occurs over here? So in roasting, what we do is that the ore which is there, it is heated in excess supply of oxygen. So whenever there is an excess supply of oxygen or air in that process, in that situation, roasting occurs. Whereas for calcination, if we see the ore which is there, it is heated in limited supply. In limited supply of oxygen. Okay, so major differences in roasting, there is excess of oxygen or air that is provided, whereas in calcination, this process occurs in limited supply of oxygen or air. Now, the second question is, the metals high up in the reactivity series cannot be obtained by heating with carbon. So, now let's look at the reactivity series. We have, okay, so we are talking about this most reactive part over here. So now when we talk about the most reactive part, we have to understand one thing, that when we have a metal oxide and over here the metal is most reactive or it is highly reactive. Okay, so in this case what is happening is that this metal which is there, it is having higher affinity towards this oxide. Okay, so say we have sodium NaO2, okay, sorry, Na2O3. Okay, now in this case, see here, this is most active or it is highly reactive, so it is going to have more affinity towards this oxygen than the carbon that is present. So it will never want to leave this oxygen and get itself reduced to its pure metal state. So that is the reason that because these metals which are there above are highly stable, they require electrolysis for their separation, and just not by using carbon we cannot obtain their pure metal state. Moving to the question number 4. Ores of metals in the middle of the activity series such as sulfide ore or carbonate ore are roasted or calcinated. First question is, what happens when metal combined with oxygen? So metal plus oxygen, what happens? And second question is, which process, name the process that is used to obtain metals that are most reactive. Okay, so we are basically talking about the top of the reactivity series, that is potassium, sodium, calcium, magnesium, aluminum. Okay, so how do we obtain this metals? Okay, so now first question is that metal plus oxygen. So metal plus oxygen, we know it gives us MO, that is a metal oxide. So any metal when combined in the presence of oxygen, it ends up giving us a metal oxide. Now the process that is used to obtain these metals, we know that just now we discussed what, that the metals which are there above carbon, they are more, they have more affinity towards oxygen. So they would not want to leave out oxygen and get reduced just because of carbon. So in these cases we use the process of electrolysis. lysis. So in electrolysis we usually use so that we can separate out this metals from their metal oxides. Moving to the fifth question, metals in the middle of the activity series are moderately reactive. Which is the most reactive metal in the series? So if we see, the most reactive one is the first one, so that is potassium. So the most reactive one is potassium metal. Second is copper loses its shiny surface over time and gains a green coat. Write the chemical name of the green coat. So now, say we have copper. Okay, so what happens is copper over the time, say it reacts with carbon dioxide that is present in the atmosphere. Okay, so the level of carbon dioxide that is present, these both of them, they react over time. So over time what happens is that this carbon dioxide comes and combines with copper. So that is what leads to the formation of that green coat, and that green coat is the basic copper carbonate. Okay, so when copper reacts with this carbon dioxide for a longer period of time, it loses its shiny surface and it attains a green coat that is of basic copper carbonate, that is given as CuCO3 dot CuOH. So this is a basic copper carbonate. Question 6. Refer to the given reaction. So here we have four sets of reactions that are given. First one is calcium reacts with water. Second, iron reacts with steam. Magnesium reacts with hot water. Sodium reacts with cold water. So from this, the first question is, which is the most vigorous reaction? Okay, which is the most vigorous reaction in from the above. So now if we see, calcium reacts with water, no. Iron reacts with steam, no. Magnesium reacts with hot water, no. But there is one reaction in our textbook that tells us that is the sodium one. That sodium which is there, it is highly reactive with cold water. So what happens is that the minute you drop any, like a piece of sodium into cold water, it is going to be a highly exothermic reaction. Exothermic as in a lot of heat is going to be evolved. Okay, so that is the reason that it is going to be the most vigorous reaction. So over here, sodium reacts with cold water. So this is the one of the reasons so as to why sodium is never stored openly. It is usually stored in kerosene oil that is there. So these pieces of sodium, they are stored in kerosene oil instead of cold water, because it is highly vigorous and it is highly reactive. Next question from the same set is that, which of the above metals show the lowest reactivity with water? Now lowest reactivity with water is iron when it reacts with steam. Okay, so no other reaction over here actually shows any major reaction except for when iron reacts with steam. So for second one, it is iron reacts with steam. So most vigorous is sodium reacts with cold water and least reactive is iron reacts with steam. Next question. In the electrolytic refining of copper, name the electrolyte used and what is anode mud. So first one is, there is basically refining of copper. So we have to tell what type of electrolyte is going to be present. So it is, name the electrolyte. So if we have the metal as copper, so its solution is also, we use the same one. Okay, so over here if we have in electrolyte, that is the aqueous form. Electrolyte meaning it is the solution, in the solution. So this is refining of copper by electrolysis method. So in that we know we have anodes and we have this electrolyte, the solution which is there, in which the electrodes are dipped, that is the electrolytic solution. So in this case, if our metal is copper, so we are going to have a copper based electrolyte itself, and that is going to be acidified copper sulfate. Okay, so our electrolyte over here is acidified copper sulfate. Next is the what is anode mud. Okay, now anode mud is what we know. We have a cathode and a anode in this case. Okay, so say this is a cathode, this is a anode. Now what we do is that the cathode which is there, that is usually considered as the pure metal. So a strip of pure metal it is. Whereas for anode, no, we use the impure side. Okay, whatever is the whatever we want to pure out, the impure side we use at the anode. So that is the reason why this is known as the anode mud, because it is having all the impurities that are present. So such impurities like gold, silver and platinum. Okay, so because it is having these impurities that are present, so therefore we refer to it as the anode mud. Moving to the 8th question, we have name the following. So the first one is name the reaction of iron oxide with aluminium which is used to join railway tracks. Now when we talk about railway tracks, okay, so there is one reaction that we know is iron with aluminium. Okay, and this is a highly exothermic reaction. Exothermic as in a lot of heat is released out in this reaction. Now when we look at the exothermic word itself, the thermic part of it tells us that it is a known process that is known as the thermite process. Okay, so over here the reaction of iron oxide with aluminium is a highly exothermic reaction, and from the exothermic word itself tells us that it is the thermite process that is used. Second, name the following is that name one of the ores of mercury. So one major ore that we know is the cinnabar ore. Okay, the cinnabar ore, which is also given as HGS. So this is one of the ores of mercury. Moving to the 9th question. What principle is the basis for separating gauge from its ore? So basis for separating gauge from its ore, it depends on the difference in its densities. Okay, so which depending on which one is heavier or which one is lighter, or it is also depending on their chemical composition. Okay, so it depends mostly on the difference in their densities or their chemical composition. Next question is, at which electrodes are the products of electrolysis of calcium chloride liberated? So say we have electrolysis of calcium chloride that is happening. Okay, so it is CaCl2. So in this case we have our cathode and we have our anode. So mostly we relate cathode to be the positive electrode and anode to be the negative electrode. Now if we look over here, CaCl2. So in this case we have calcium. So calcium is positively charged, and chlorine which is there, it is negatively charged. So this one becomes our cation and this one becomes our anion because it is negatively charged. So over here at cathode we will have our calcium, because mostly at the cathode we have the pure metal states that are present, and at anode we will have the chlorine. Okay, so in this we will at cathode we'll have calcium and anode we will have the chlorine. Moving to the last question, we have give reasons for the following. zinc oxide is considered to be an amphoteric oxide. So we have to give reason why zinc oxide is amphoteric. So if we say it is amphoteric, what does it mean? Amphoteric tells us that it will react with both. It will react with bases as well as it will react with acids. So amphoteric nature tells us that any metal or any oxide which is there, it is going to react with both of its acids as well as the bases. Second is give reason for reaction of nitric acid with metals does not generally evolve hydrogen gas. So now previously what did we say? When we have metal that reacts with acid, okay? So over here the products are salt plus we get hydrogen gas that is liberated out. Now when we have nitric acid, this usually is not followed, okay? So one of the major reasons is that nitric acid, it is a strong oxidizing agent. Okay, so it being a strong oxidizing agent, what it will do is the hydrogen which is being produced, no, so somewhere H2 will be produced. Now since it is a strong oxidizing agent, it will reduce this, okay, it will reduce this to H2O. So instead of hydrogen release, we will end up getting a water molecule. Why? Because nitric acid being a strong oxidizing agent, it is forcing this H2O to reduce itself, it is forcing the hydrogen which is there to reduce itself to a water molecule. So that is the reason. This is an exception wherein nitric acid, when it reacts with a metal, it will not give us a release of hydrogen gas. Instead, it gives us a water molecule as a byproduct. Okay, so that was it for today's video. We hope you have understood. Please don't forget to like, share and subscribe to BodhiAcademy.